All right, today we're going to dive into a pretty simple idea that could completely redefine solar power as we know it. We're talking about a technology that targets a hidden and really costly flaw that exists in pretty much every solar panel system on the planet. So let's get right into it.
So, to really wrap your head around why this technology is such a potential game changer, we first have to ask a fundamental question. What exactly is solar energy's hidden flaw?
Well, it all boils down to a very simple and honestly kind of brutal principle. You might have heard of it, the weakest link effect. Your entire solar array doesn't matter if it's a few panels on your roof or a massive solar farm stretching for miles, is only ever as strong as its single weakest panel at any given moment.
Now, this whole problem has an official name. It's called mismatch loss. See, in a standard solar setup, all the panels are wired up in a series, kind of like old school Christmas lights. And just like those lights, if one panel's current drops, maybe from a passing cloud, a bit of shade from a tree, or even just some dust, the current for the entire string of panels gets choked down to that one lowest level.
And the result of that is, well, it's staggering. Just one panel getting partially shaded can slash the output of that entire string by up to 50%. I mean, think about that. Half of your potential power just gone in an instant, all because of one little shadow. That's a massive amount of wasted energy and, of course, lost money.
Now, of course, the industry has known about this problem for years, and they have come up with some solutions. But, as we're about to see, these first-generation fixes, well, they come with their own pretty serious set of limitations. The current generation of fixes are known as module-level power electronics, or MLPEs. The big names you might recognize are power optimizers from companies like SolarEdge and microinverters from companies like Enphase. What they both do, essentially, is put a tiny complex computer on every single panel to manage its voltage. They're trying to fight the symptoms of mismatch loss, but the problem is they're complicated, they're expensive, and they create their own heat and efficiency losses along the way. And this really points to a multi-billion-dollar blind spot in the market. You see, these complex solutions were really designed for residential rooftops. They work fine there. But when you try to apply them to those massive utility-grade solar farms, the economics just completely fall apart. They're just not built for that kind of scale. And this is where a simple but truly radical idea enters the picture. What if, instead of constantly fighting the symptoms by trying to manage all that complex voltage, what if you could just solve the root cause of the problem directly? This really shows a fundamental shift in thinking. The old way is all about fighting the symptoms, right? Managing voltage with all this complex hardware. But the new way, the IPC way, goes straight for the root cause. It focuses on controlling the one thing that actually matters, the flow of the current itself. It solves the problem at its source. So how does it actually do that? Well, the process is beautifully simple. First, the Intelligent Panel Controller, or IPC, is constantly sensing the current in real time. Second, its brain is instantly deciding, running these little simulations, asking, hey, what if I temporarily switched these two panels from a series connection to a parallel one? Would that boost the whole string's power? And third, if the answer is yes, it switches the circuit in less than a second. It's that fast. You know, the source material uses a fantastic analogy for this, and it's perfect. Think about being on a highway where one lane suddenly gets blocked. Everything grinds to a halt. The IPC is like a smart traffic controller that instantly sees the blockage and opens up a brand new lane, the parallel circuit, to keep the entire flow of traffic moving at full speed. The concept is elegant, for sure, but does it deliver in the real world? This is where the technology becomes what you'd call an economic knockout. The numbers, well, they tell a really compelling story. I mean, this slide really says it all. Just look at the cost per watt. A traditional inverter is about 8 cents. You add a SolarEdge optimizer, and you're at 18 cents. The premium Enphase microinverter, a whopping 45 cents. And then you have the IP system clocking in at just 3 cents. It is a tiny fraction of the cost, while delivering a better efficiency gain of nearly 21% over a basic setup. Let's just focus on that number for a second. 3 cents per watt. This isn't just a small improvement, you guys. This is a complete disruption of the entire cost structure for panel-level tech. It fundamentally changes the economic math for building solar projects, and it even includes critical safety features like rapid shutdown at no extra cost, which is huge. So we know it's cheaper, but does it actually produce more power? Well, according to industry standard simulations, absolutely. For a typical home system, it doesn't just blow past a traditional setup. It actually outperforms the market leader, Enphase, generating over 3% more energy over the course of a year.
So let's just put a bow on it. When you compare it to a standard, unoptimized system, you're looking at over 20% more energy being harvested over the year. That's the core value proposition right there. Significantly more power for a fraction of the cost. It's a no-brainer. But this kind of leap in performance and cost, it's not just about making a better gadget. It's really about enabling a fundamentally smarter energy grid for everyone. This combination of incredibly low cost and high performance, that's the key. That's what finally makes advanced panel-level optimization economically possible for that massive utility-scale solar market we talked about earlier. A multi-billion-dollar frontier that, until now, has basically been out of reach for this kind of tech. What this tech really creates is what the source material calls an intelligence layer for solar. This allows operators to remotely control individual panels, slash their operations and maintenance costs, and it even lets solar farms participate in advanced grid services like virtual power plants, which opens up totally new ways to make money. And the ambition doesn't stop there. The roadmap for this tech includes integrating predictive AI to use weather data, becoming a central hub for battery storage, and eventually evolving into an autonomous node that can actually enable peer-to-peer energy trading on a decentralized grid. The ultimate vision, as stated in the source, is crystal clear. The goal isn't just to be a hardware manufacturer. It's to evolve into an entire intelligent energy platform, creating a whole new ecosystem for the solar market. Which really leaves us with a final, pretty provocative thought. By focusing on such a simple, elegant solution to the fundamental problem of current, could this be the key that finally unlocks the door to a truly intelligent, efficient, and decentralized energy grid for all of us?